Let's see if it reconnects. I'm curious.
What the heck?
I'm curious if it's working. I had like 2
Come on,
streams.
OBS, I believe in you.
Oh, hey, it is working. Cool. Hello, everyone. Thanks for joining us. We're getting a new whiteboard set up because people feel the need to interfere.
Yeah, it's fun. Looks like apps kind of freak out. Second.
I can just open up Microsoft Paint for now.
Yeah. Why don't you just do that instead?
Okay. So we're going to cover the very fundamentals of Git, and as our example, we're going to use. Oop! I didn't mean to open up Steam. As our example for an interface, we're going to use GitHub. Okay, so what is Git? Yeah, see, Hickory, I'm wondering the same thing. Who did write that? The link to the whiteboard that we were using was public, so whoever copied the link and put it in could join. So I'm assuming somebody watching the stream hopped in and did that. So fun times. Okay, so what is Git? Git is a version control system. And what that means is it allows you to have different versions of your system stored and allows you to go back a version, right? So let's say you're working on a feature and you're adding a button. Well, if you mess that up and you make a bug, you can go back to the previous version. It also, if you have some sort of server or UI that you're using that you're connecting to, or a hosted Git service, it allows you to store backups to whatever server that is. And in this case, the server that we're going to use is GitHub. And GitHub has this nice friendly UI that wraps around how Git works. And it allows you to store things on GitHub so that if your computer crashes, it's all stored on GitHub. So I highly recommend whatever code you're working on, you'd upload it to GitHub, and that would allow you to have a safety net that basically allows you to prevent your code from being lost. In the event of I don't know, a fire in your home or you dropping your computer down a 12-story building. I don't know. Okay, so what we're gonna do, Zach, I'm just gonna go ahead and create a brand new one-leaf repo for this tutorial purposes, and then we can delete it after if we want. Actually,
Okay.
do I have just an empty repo? Getting started.
No,
I do have one. Actually, I want to walk them through the process of creating it.
Okay. I'd make one that I can also contribute with, so then we can.
It'll just be a one-leaf repo. Okay,
Cool.
so on GitHub, this is a GitHub specific thing. You can have different teams. So for example, our team is one-leaf. And what that allows you to do is you guys can interact on each other's projects. So for example, I could go into our website project and make changes to it. And you can also add permissions so that the administrators have to approve of the changes that have been made and whatnot. So what we're going to do is we're going to make a new repository. And a repository is just a grouping to hold your code. So we're going to create a repository and we're going to call it csfundamentals-git. And we'll give it a description. This repository is used to test and learn Git. And we're going to make it public so anyone can see it. That's kind of the beauty of GitHub, is your code is public, and that hints on one of the beauties of open source. Open source meaning that your code is open and free, so that way, if we're working on a project, for example, any of the one-leaf projects that you're working on, you can go see any of the games we're working on, any of the websites or apps that we're working on, and the code is out there, and it's a great way to learn. Central to a Git repository would be 3 preceding setup steps. And the first one would be to initialize with a README. And this will basically let you have a landing place. README meaning like, hey, I'm a file, you should read me. This is how you get set up and get started. And then you can add a Git Ignore. And this basically says when we're uploading files, let's ignore files relative to what you're doing. So for example, the one that I always use because I'm a Unity developer, I would click Unity and it would give me a Git Ignore that would, ignore temporary files, ignore builds, ignore logs, because we don't want to upload those things. We don't care about those. They can be deleted and we can regenerate those temporary files, right? I'm going to leave it on none because this isn't a Unity project. This is just a test. And then you can add a license, and what a license does is it licenses your code, and it's a legally binding document that basically says, here are the restrictions to use our code. On almost all of our repositories, we use the MIT license, which basically says, you're free to use our code as you want. We don't have a warranty. We're not liable for what you do with it, but do with it as you will. And that's kind of our goal, is to give you guys some tips, give you some starting places on how to do these things. So we'll go ahead and create the repository. And once the repository is created, you'll see we have 2 files in it. We have the license, we have the README, and down here you can see we have the README again, and it has like a default output of what's in the README. So in here, we could put, if we hit the edit button on the README, or if we click on the README file itself, we could go edit it, and we could add in some description as to the project. Say, this is a one-leaf project, etc. And then we'd commit those changes. And what a commit is a bundle of files that you've changed that represent some piece of work. So in this case, you see how it kind of has the placeholder for update readme? We'll just call it update readme. And when we commit it, we're committing it to the master branch. We'll get to how branches work in just a second. When we commit it, you'll see, if we go back to our code and we go to our commits, you'll see we have two commits. We have the initial, that when we created the repository, it has the license file with the MIT license in it, and it has the README with the README that it created. And the green lines are ones that were added, and we didn't have any deleted lines, but they'd be red. So it shows you the differences between the files in between commits. If we go back, we can see the update README. We can see the one line that I changed when I committed, right? And now all this code is up on a server, right? It's not on my computer. It's up on one of GitHub's servers, meaning it's just on one of their computers stored in one of their databases. So what do we need to do? We need to bring it to my computer so I can work on it. And you do that by clicking on this green button right here, and you can either clone or download. Cloning means I clone the entire Git repository. I want Git to kind of handle how things change. Or you can download it, just meaning I don't want to handle it with Git. I just want to download the files itself. We're going to clone it, and by cloning it, you go to github.com, and then the name of your organization or your user, the name of the repository, and then .git, which is basically just the location of the repository. So we'll hit the clipboard button to copy it. And I'm going to use Git Bash, which is a Windows terminal. It's just a Windows emulation of like a Linux or Mac terminal. And it's going to have a lot of the similar commands to how a terminal would work on Linux. And one of the packages that that you need to have in order for this to work is Git. So if you just type in to Google Git download, you go to git-scm.com, and it will give you tutorials on how to install it for each of the operating systems. And once you have it, you can do it through the terminal. We're doing it to the terminal to start because all the commands will be the same, and that's super important because we're trying to make this as useful to as many people as we can. Okay. So if we go back to our terminal, we want to go to wherever we want to store our project. In my case, I like to store my files in documents/coding. And now we're going to type in git. And if I just hit enter, you'll see in most operating systems, if you just type in a command, in our case the command is git, it'll output all of the options. In this case, we want to clone it, which clones the repository, meaning it copies it from their server to my machine and makes it into a directory. So we'll type git. Oh, let me clear and make this not so dirty. So we do git clone, and then I copied the link. So I highlighted over that, so I copied it. Now we gotta go copy it again. Okay, so we do git clone, and then the name of the repository that we want to copy. And then you'll see, here's all the files it's downloading, and then it'll tell you that it's done. And if we list all of our files, you'll see that we have the what did I call it? CS fundamentals-git, right? And if I go just into my folder structure, go to my documents, coding, you'll see I have my CS fundamentals-git folder. What does it have inside of it? It has our license, our README, and this .git folder. And the .git folder is what allows Git to know what's been changed since the last time you touched things. And Git doesn't track the current state of your project. All it tracks is what's changed since the last time you've edited it, right? Which allows it to be a lot smaller in its operation. Okay, so we're going to go into our CS fundamentals-git folder. And now you'll see we have this extra addition to my terminal in parentheses, and that tells me what branch I'm on, right? So let's talk about branches. If I open up Microsoft Paint, so a branch in Git is kind of like a timeline. So we're gonna use vertical timelines here. The main branch that GitHub will give you when you start, I'm gonna use abbreviations because I don't want to type out text because I'm lazy. M is for master, D is for development. So if we go back to GitHub, you'll see under branches, all we have right now is master and Zack's branch that he made. Usually the way that it works is when you initially create the repository, you have your initial commit, and we're going to use circles to represent commits. And as you saw, commits are just a bundle of files that says we've changed something. So we had our initial commit, which just had our README and our license, and then we had another commit that represents the change that I made to the README. And then what we do at this point is we'd branch off of master and make a separate timeline called development, or develop, whatever you want to call it. And what this timeline is for doing development work. When you're done doing your development work, you take this timeline and you'd put it on top of the master branch. And you'd only do this for versions, right? So let's say we're at version 1.0 or 2.0 or whatever. And it's kind of beautiful in how it works, because now this master timeline, this master branch, only has, built versions that are stable and ready to go, right? Depending on the way your testing works and whatnot. But okay, so we're not ready to merge back into master. We just have this development timeline, right? And so the first thing I do as soon as I make this development timeline is every piece of work that I do, and this is how it works for all of our open source projects on OneLeaf. Um, we'd branch off of development and create a feature branch or a bug branch. And we'd say, we're doing feature, I'm just going to use F for feature slash, and I don't know, B for button, right? And we're going to add a button to our UI. And let's say we add a commit to create the button and add another commit to add functionality to the button. And then we'd merge that back into development. And when we merge that back in, we use what's called a pull request. And a pull request says, hey, here's what I'm trying to do. I'm trying to add this feature. I want to add a button, right? And before my pull request can be merged back in, you need people to review your code. So we will go ahead and walk through this process so you guys can see how it works. If you ever want to hop on into the if you ever want to hop onto any of the OneLeaf projects, this will be the process for being able to work and manage a Git repository. So we're in our Git command line. We're on the master branch. If we do git branch, it'll list out all the branches that we have on our local machine. In this case, it's just master. And you can see master is green and it has a star next to it to show that we're currently on it. If I do git branch -r, you don't have to remember all these commands. I'm just trying to show you something. You'll see we have origin master, right? And Zack created another branch called 0xleaf dash patch 1. And that's a separate branch, right? And the R shows all the remote branches, all the branches that GitHub knows about, right? So what we want to do is we want to make a new one called development. So we want to do git checkout, meaning we're going to check out a new branch or create a new timeline. And B means we want to create a branch when we check out, and we're going to call it develop. And now you can see our branch has changed to develop. If we do a git branch, you'll see we have two branches, develop and master, and develop is the currently highlighted one, and that's the one we're on. And now if I just do a git push to say, hey, Mr. GitHub, we want you to know about this branch now that we've created it, it'll say, we don't have an upstream branch. We don't know about this development branch. So what you have to do, you can just copy the command that they give you. And basically what it does is it says, we want to say, hey, Mr. Origin, I want you to know about this development branch. And when we run it, and we go back to GitHub, and we refresh the page, now in our dropdown, we can see we have our develop branch. If I go to it, you can see we still have 3 commits, or I guess Zack added one. He updated the README again. But on the master branch, we also had 3 commits, right? So our development branch is in the same state that our master was, right? So when we broke off this timeline, we're at the same state that we were beforehand, right? So now, this would be the state that you would like come onto our projects, right? You're on the development branch, you've gotten the latest code, and you'd get the latest code by doing Git Pull. And once you've cloned a repository, once you've been on the right branch, you hit Git Pull, and all that'll do is you can see here Zack added patches to his updates. You can see he has patch 1 and patch 2, and Pull just pulls down things that our local Git repository doesn't know about. Actually, I feel like I've been talking a lot. I need to check the stream quick. Okay, we're good. So, whenever you are about to work on a new ticket or a new piece of work, you do a poll to make sure you have the latest code, right? We make sure our timeline is updated before we branch off and make another timeline in the multiverse. So, let's say in the majority of projects, you'll have some sort of board, right? You'll have some sort of project board that'll keep track of tickets. And in GitHub, they have this thing called projects and their boards, and we'll just call this project board version 1. And then we'll create the project. And the boards, they can be organized however a project manager likes, but the way I like to do it is you have a backlog, which is this says these are the pieces of work that we don't know what we want to do with yet, but we know that we're aware of them. We have to do, which is going to be a column of cards that we are ready for work on. We have in progress. These are tickets that people are currently working on. We have in review, which are tickets that are done and we're waiting for people to review them. And then we have done, right? So I'd start by in the backlog, I'd say, add a button, and then I'd add that ticket, and then I'd create another one called, I don't know, update readme. And then, let's say we've been talking with the team and we decided, okay, these two things are ready for work. So we click and drag them into to do. And now our ticket that we assigned ourselves to, you can see Zack here is adding some issues. When we just create the card, it's not linked to anything. It's not an issue. So in GitHub, we have this concept of an issue, which would be like a bug report or something that you want to create. So we'd convert this card into an issue. And all that does is you can see it gives you a link. And if we go to the Issues tab, you can see we have these list of issues. And so now what we can do is if we click on the issue, we can assign someone to it, right? So we can assign any of the OneLeaf members to it. So I can assign myself to it. And I move it into in progress. And I say, this is my ticket. I'm going to add a button, right? And usually there would be some description, telling you what to do. It would say, add a green button with this size, this roundness, and this is the text that it needs to hold. We're not going to go through all that, but we would give you that level of description so that way you know what this ticket is. It's not just add a button because you wouldn't know what to do. So what we're going to do is we're just going to create a new branch, and we'll call it Git Checkout, and we'll check out a new branch, and we'll call it feature/create button. And so now you can see our branch is on feature/create button. We just prefix it with feature/ so that we know it's a feature. If it's a bug, it would be bug/, for example. And if I do a git branch now, you can see we have the development branch, we have the master branch, but we're currently on the feature/create button. And let's just, in our Git folder, we'll just add a new file. Come on, pop up. I believe in you. And I don't know, we'll just add a text document. We'll say button. In reality, this would be like actual code, right? And we'll, I don't know, we'll pretend this is HTML, and we'll put button and some text inside of it and close the button. I'm just using HTML as an example because it's super simple. Okay, so now that we've made our changes, right, we want to be able to give those back to GitHub and have people review them. So let's check what changes we've made. If we type in git status, it'll give us a status of files that we've changed. So it says we're on branch create button. We have this untracked file, and our untracked file is button.txt, the file that we just added. And it's untracked because Git doesn't know about it yet, right? It's untracked because we haven't used it before. We can't track what changed since the last time we touched it because we don't know about it yet. So we can do a git add, and this basically adds it to a staging area. So now if I do git status, you can see it's green, and these are changes to be committed, right? So if we go back to Paint, and let's undo all of our changes here, we have like 3 areas, right? We have U for untracked, we have S for staging, and we have C for committed. So we have file 1, file 2, and file 3. And let's say these 2 are some temporary files that we don't care about, but this one we want to give to GitHub and have people look at it. So we do git add to move it to the staging area, right? And now we have number 1 in here, and he's not over here anymore. What we want to do then is we want to bundle this into a unit of work, or a unit of, how do I want to phrase this? We want to bundle it into a unit of files that resembles some piece of work. For example, in this case, it would be we created a button, right? And by doing that, we make a commit, right? And a commit says, hey, I have this unique ID representing my change. I have some message telling me what happened and what time it happened and who the author is, right? And then when we're done making the commit, we say, you go to GitHub so that people can check it out. So now that this guy's been added to the staging area, we do git commit. And if we add -m, we can give it a message, right? And we can say added a button. And so now when I do git status, I realize there's a lot extra going on here. If we did the git status after adding it, it says these are the changes to be committed, right? They're in that staging area. If we do git commit -m, you can see one file was changed, which would be our button file. And if we do a git status, we have nothing left to commit because everything has been committed, right? Our working tree is clean. There's nothing else that needs to be updated, right? And if we do a git log, we can see all the previous commits. We have the commit that we just added, and it has this unique ID, which is actually a hash if you were watching the last video. We have the author, we have the date that I did it, and we have the message of the commit. I added a button. And you can also see the branch that this was performed on, right? And then you can see the previous commit. Zack updated the README. You can see who did it, the time, its unique commit, and you can see it was on master in the development branch, right? And then you can see the two before that. So now that we have our commit, what do we want to do? We want to tell GitHub that this exists, right? So we do git push, and this pushes it up to Git, but we created another branch that Git doesn't know about. So we need to set our upstream or tell Git that this branch exists. And so now you'll see that it takes some time uploading the files, and then I can say it's set up to track the remote branch. Remote always means whatever server we're connecting to, in this case GitHub. And so now if we go back to GitHub, and I go back to our code, you'll see this yellow highlight saying, oh hey, this guy was created less than a minute ago, and he's a new branch, right? Do you want to compare it and make a pull request? The other way that you do this is you go to the pull requests tab, and it would show you here as well. But we're gonna create it manually and not follow their handy dandy UI that they have here. So we create a new pull request, and how do we want to change these things, right? We want to if we go back to our timelines, can I even undo that far? Nope. We have our master branch, we have our development branch, and then we have our feature branch off of it, right? Well, we want to take our feature branch and merge it back into development, and then we check out another feature and we merge it back into development. So we're going to create a pull request, taking this commit and putting it on top of the development timeline. So we want to take it from my feature branch and move it into the development branch. And you can see it shows the file that was changed was button.txt, and it shows you the line that was changed in that file, right? So if we create the pull request, it allows me to add a title and a description. It's pretty descriptive how it is now. So I'm going to assign myself as the assignee of the pull request because I'm the one doing it, and then I'm going to add Zack as a reviewer of the pull request so that he can review it. Okay, so now you can see here's the commit that I made. I requested a review from Zack, and I assigned it to myself, right? Well, we didn't add any permissions to this GitHub repository, so it's letting me know that I could merge it. But if we set up permissions, it would be red. And you can see Zack added a review to my pull request, and he added a comment saying nice, right? You can go into the commits and look at the individual commits. You can go into the files changed and see all the files that were changed. And if I were not the owner of this commit, I could add a comment, and I could either just comment on it, I could approve it, or I could request changes and say, hey, you need to change this. You can't submit this pull request until it's done. And if the permissions were set up correctly, which they are on all of our other repositories, this button would be red and it wouldn't allow you to merge. But now that let's say Zack has approved, I can hit the merge pull request, and then I confirm it. And now you can see if I go to the master branch has 3 commits. The develop branch has 7 commits. Okay, Zack added some extra stuff. And you can see my commit for adding a button and a separate commit for merging that pull request from my feature branch into the development branch, right? And you could go look at these individual commits if you wanted. And so now what we want to do, if we go into this box, or if we go look at all the branches that we have, we no longer need the feature/create button branch anymore because we're done with that timeline, right? It was a temporary timeline. So if we go back to the pull request that we closed, you can see we have one open pull request, the one that the one that Zack made. We can go look at that in a second. And we have 2 closed ones, right? So our added a button was closed. And we can go ahead and delete this branch now because we don't need it, right? So if we delete the branch and we go back to our code, you can see it no longer exists here, right? So we can kind of keep this from getting cluttered, and we can see which branches are active in development. Master and develop will always exist, and then you'll have all the other ones. So for example, Zack here has patches, right? Okay. What questions do you guys have? I feel like I talked a lot. Oh, sorry. One last update.
You want to wait? Oh, sorry. You want to wait for questions and then go through that PR that I have set up?
Yeah.
Also, since you merged in your code, you have an issue up for what you were working on. You want to tail that?
My stream's a little bit behind.
Oh, okay. Yeah.
So when I submitted the pull request, I would have put it in review, and then when it was merged and approved, I would put it into done. So that way we can track each unit of work where it's at. And you can see Zack go ahead and he had this create some big file that he created a pull request for, and it's in review. So if I go to his pull request to show you guys how this works, we can see all the things that he's done, right? He self-assigned it, he requested a review from me, and so on. Let's go to the files that he changed. He added this is new, and he added a link to our website, and he added some just placeholder text, right? And we're gonna say, yeah, this is exactly what we wanted on this project. So we're gonna review the changes. Actually, let's show him how request changes work. And we're gonna say some big file has some typos. And if we submit the review, you can see he can't merge it anymore. It's grayed out, right? And you can see like if we just scroll down, you can see a big red box that says, "Hey, I requested changes, and here's the comment that I made." Right? So Zach can now go update his changes. I don't know, just go change something, Zach.
Okay, 1 second.
Let me know when you're done. So he's going to do the same thing. He's going to go to his branch. He's going to update something. He's going to commit that change, and then he's going to push it up to GitHub.
All right. Updated.
All right. So if we refresh the page, you can see there's 5 commits now. We go back to his files changed. I don't. Oh, if we go to commits, you can see what's changed since the last commit. Oop,
You'll see a commit right after
so you
if
can
you
see
refresh.
the latest one is on bottom. It was updated 20 seconds ago. We can see all he changed was he added one leaf to the end, right? So now we can approve it and say, this looks great. And we submit the review. And now you can see, okay, I'm not the owner of the pull request, so I can't merge it. Also, there's merge conflicts.
So yeah, this is my little scenario of someone asking, hey, when do you merge or when do you rebase? So I have a PR, I have code that looks good. Everyone said it looks good. The only issue is I have some conflicts. And if you click on resolve conflicts, you can see specifically which conflicts I have. One being the top one, my branch, leaf patch 1, and the bottom is develop. And so much has changed in this file where Git can't find out which one to take. So it asks us which commit or which changes to this file do we want? Do we want our changes in this branch on the top, or do we want developed changes on the bottom? So Sabian, could you do me a favor and instead of just conveniently changing it on the web,
We're going to go into the command
could you,
line.
and can you do a merge into from develop into this branch? Because that's ideally how you solve this.
So we're going to make a pull request from develop into that branch. And this might be a little confusing. Let me pull up Paint here real quick.
Yeah. You could also just do it just in the terminal and just merge locally.
Got it. Well,
Yeah, it might be better to do visual
yeah, I'm thinking that as well.
PR. Let's do
So
that. Let's do
so
that.
Zach created one commit, and then I told him he needed to make another change, so he made another commit. But in the time between when he made these changes and when we created things, the file that he edited was changed, back on this timeline, right? And gets like, whoa, you made changes. Which ones do you want to keep, right? Let's say that you're making a game and one person changed the movement speed to 5 meters per second, and beforehand it was 4 meters per second. It's gonna say, something's going wrong here. One of you should figure out, which one's the right answer. So he tried to merge it back into the development branch here, right? And when he did that, it told him he couldn't because what's on the development branch is different. So what we're gonna do is instead we're gonna take before we merge it in, do do do. So we have these
And
two commits.
specifically, sorry, to
Go for it.
touch a little bit more, just it's not that it's just different, it's that our base versions are different. Say, or my PR right here is branched off of something that was correct. And now that I'm merging into develop, something else was merged in before that changed it. And now I'm trying to merge it in. That's why it's fighting. It's not always that anything in any branch that's different is going to fight.
No, yeah,
It's
that's a
just that
good
it's
good
changed
clarification.
in the span that once you've based or once you did the git branch off of wherever, if that changes, you just need to update that. And that's what we're going to show you how to update.
To illustrate that, if Zach tries to push in here, but I made a commit, like let's say I pulled out a feature branch and pushed it back in, and when he tried to merge his branch back in, it checks, all of the changes that he made here against the ones that have been made in the meantime. And it says, are any of the files different? If so, were any of the same lines touched? And if they were, you have to figure out which one of those lines you want to keep. So what we're going to do instead of merging it in is we're going to take Mr. Development branch and we're going to put him, the commit that happened here, we're going to take him and put him on top of our branch. And then when we're done, we'll merge all of it to development. I'll let you the illustration catch up, Zach. I want you to double check and make sure that's right. I could be 100% misunderstanding.
Yeah, okay. Think so. I just see it circled now.
When you get to the
So
red and the
yeah,
orange.
okay. Didn't see any colors yet. Yeah, it is a little behind. So why don't you touch on a question really quick while someone's asking? GUI versus command line.
So benefits of each of the okay, so you can use a GUI. So I was going to get to this in a second, but for example, instead of using the command line to do everything, I have, for example, Github Desktop, which is a GUI, right? Like I could go in here and I could see each of my individual commits like this, and if I went and changed a file, it would show up here. I think the GUI is easier to get into. However, GUI meaning graphical user interface. It's some user interface that you react with instead of having a command line arguments or command line functions. I think it's best to start out kind of trying to do a little bit of both. I think it's really important to understand what's happening when you press the buttons on the GUI, what commands it's calling. So, for example, if I just hit push on a new branch in the GUI, it would do this set upstream for me, and you may not understand what's happening under the hood. But once you understand everything that's happening under the hood, there's no reason not to use a GUI if it's quicker for you and you feel like it's easier. Anything to add to that, Zach?
The main part, the reason why you should and shouldn't use a GUI is you should use a GUI on your local machine for ease of development to make sure you're committing the right files and the right changes. Graphical GUIs can do cool things of even editing files to handling conflicts, merging, and stashes, and all this nice stuff. The thing, though, about the command line and why it's good to practice on the command line and be proficient on it is because you don't get a GUI Git for SSH. When you're on a server or on a build machine, and you're SSH'd in and you're just doing command line, you don't get that whole graph and all this nice stuff. You really need to understand what's happening because regardless of what Git GUI you're using, it's using all of the same commands: git add, git push, git pull, git branch. All those are the same regardless. So whatever Git GUI you use is ideally just whatever the command line thing is we're teaching you right now. So they're the same function. So as long as you understand that, then you're good. But if you only use a Git GUI, then at some point, if you need to SSH into a build server or a server, and you need to do some Git command line stuff, then that's going to be difficult.
Yep. Yep. Good points. Okay, so we covered the very fundamentals of Git. I'm hoping that really sticks with you. Every project that you do, you should try and do with Git so that way it's backed up and you learn how to use these things because it's going to be really important when you're working with a team.
Yep. Did you want to finish that example really quick?
Oh, I spaced. What were we doing? Oh, the
So just
merge.
make
Sorry.
it, yeah, just do it. Yeah, no, you drew it out and then we were taking the question. So yeah, if we set up a PR from develop into my branch that I'm trying to merge into develop,
Was it patch 1 or patch 2? I forget.
it was patch 1.
I'm going to go double. Yeah, it's patch 1. Cool. So basically we're saying instead of, putting our timeline on top of the can't automatically, we're having the same problem.
Which one?
When we merge develop into patch 1, we're having the same can't automatically merge. It's going to have conflicts.
Yes, no,
Yeah.
so that's the point. That's
Yep.
the point.
Yep.
So the point is, regardless of if you do this on GitHub or if you regardless you do this on local, you're gonna get the same thing. But the thing is, if you merge in wherever you're trying to merge to, so let's say I have my branch, my patch branch, and I'm trying to merge it to develop, and I have conflicts, or whatever branch I have conflicts, whatever I'm trying to merge into, I'm gonna want to merge that into my branch. And then I will resolve all the conflicts locally and then push up the changes after that. And then after that, everything will be the same, or it will be resolved for all the conflicts because you merged develop or wherever you're trying to merge into your branch. So, I mean, you've already done the merge, it's just locally on that branch. So that's why you're going to still see it in this GitHub example. But ideally, once Sabian creates it, he can just go to resolve conflicts and then select which one he wants, which will just select the one that I put, or I'm going to select the one that I put. I'm going to mark it as resolved and commit the merge.
How do you do it on the GitHub GUI? I've never done it here.
Oh, I already did it. Sorry.
Oh, okay.
So you can click on resolve conflicts.
You can actually. Oh, I forgot it's actually an editor. So
Yep, and all you're going to do is edit that.
So you can see GitHub adds these extra characters into here. So the greater than and less than signs, right? And the equal sign is where they stop, right? So this line is what was on develop, and these lines are what was in Zack's patch. And we want to, let's say we want to keep what's in Zack's patch. So we would delete the extra line down here and delete the stuff from develop. And then we'd hit mark as resolved now that there's no more conflicts, right? So that's what Zack did. So we'll go ahead and leave
Yep.
that page and see he already did it for us. And we can see now his branch has no more conflicts and we can merge it, right?
Yep. So we'll first merge in yours. So the develop into branch one. So I'm going to merge that one in.
And you can see it automatically updates. I don't have to refresh the page.
Yep. And you merge that one in too. Yeah. So there's a better example if you do it actually locally versus on GitHub, I guess. I don't know which one got merged first.
I think this one covers the core concept at the very least.
Yeah. But the last topic of that is, well, hey, can you open up GitHub Desktop really quick and show them the graphs
It doesn't have
for
graphs,
this?
sadly. So let me change repositories
I
to
can send it really quick in mine.
just a screenshot.
Mine, yeah.
Okay.
But pretty much we can just describe what's the difference between rebase and merge with that screenshot. Because they're very, very close, but then they're very different. Okay, here's the screenshot. And I'm going to put it into streaming discussion. The screen discussion.
So you can see his has almost that same graph that we were looking at when we were drawing it out, right? I'm gonna take a copy of this.
Go to the original and zoom in, or I can take a
I'm
closer
gonna
picture, but
I'm gonna
yeah.
copy it and bring it over to Paint.
Oh, cool. That's smart.
Aha. And then we can zoom in. There we go. So you can see we have the what color do I want to use here? We'll use blue. So you can see we have the original. Oh my goodness, I'm so bad at paint. Brush. We can have we have the original two commits here, and then we is yellow develop? Yep. Okay, so we branched off and made this develop guy, and then we branched off again, and I made my added a button, and you can see I merged it in here, right? I made a new commit on development when I merged it, and also made my commit here. And then Zack branched off at the same point in time, right? We're all pointing to the same base commit. We all branched off at the same point in time. And then he made his commit, and he merged it in before mine, and mine was just put on top of his, right? So the changes between the two are basically whatever the changes between these two are. And then if we were to check it out again, it would basically just create another timeline right here. If we pulled and then made it a new branch, it would create a new branch here that we could make commits on. Yep. So this is kind of the benefit of the GUI is you almost get like a visual look at how these branches are set up.
You streaming?
Are you streaming?
Oh, are you? I'm gonna assume you're on YouTube.
Oh, Aaron, I didn't realize you were in the Discord. Yeah, we're streaming, buddy.
Oh, hi. Yeah, that's me saying, "Are you streaming?"
I thought it was somebody in Zach's background. So yeah, any questions on anything that we've gone over so far, guys? If not, then I feel like we covered Git pretty well, and we covered the data structures fundamentals pretty well. and we can call it here. And then if we have more advanced questions, we can put them in a follow-on tutorial. But I'll give you guys a couple questions to catch up on the stream because I know you guys are probably 10, 20 seconds behind.
A little bit. I'm not gonna lie, I don't even code that out. Watch, listen to them talk about it. It's like have background noise. Like
All right, guys. It doesn't look like we have any further questions. Thanks for joining us. We will. The computer science fundamentals series are more based on requests than our Discord. We don't have a weekly schedule set up for them yet. We will post them on Reddit again if we have more requests. But the C# tutorial courses, the Unity tutorial courses, and the Swift tutorial courses all have a schedule. If you hop in our Discord, we have a streaming schedule channel, and you can check those out. The Swift one is every Tuesday, and the C# one is every Wednesday. Well, yeah, thanks for coming, everybody. Zach, I'm going to end the stream unless you have anything else to say on the topic.
No, I just thanks for coming. Thanks for watching. I hope you learned a lot. If you didn't, yeah, make sure you join the Discord, ask us questions. We'd love to elaborate on the topic and actually have a discussion of this. Yeah, I don't have anything else.
Okay, I'll stop the stream here.